All righty, folks. Welcome to Thursday morning. Good to see you all out there. Still waiting on a couple of folks here, I see, all right, to join the party. So let me go ahead and get everything fired up here and ready to rock and roll. And then we will be live and living and breathing on the inside. We are indeed, once again, broadcasting live out on YouTube this morning. So you guys be on your best behavior now. Okay. All right. Thursday morning. You believe it's already Thursday morning? I tell you, I guess I'm just having way too much fun. Because it seems like it was only, I don't know, 15 minutes ago when I was welcoming you guys to the presentation first thing Monday morning. But I guess I'm just having too much fun. I guess that's probably the deal there. Let me see. Let me find our presentation for this class here, and we will be underway shortly here. Now, first and foremost, did you guys have any issues at all with any of your homework last night that you did? I worked through all of the lab exercises last night and the PBQ, and I didn't have any issues at all. I also, you'll see, I cited you a couple of the lesson reviews too that I wanted you all to do. So those were again, that repetition thing that we've talked about several times now, as far as doing the quizzes again and again and again. And that just really helps to drive home the information. And it's the repetition that really does that. It assists us in basically, working in our three different phases of memory, our working memory through to our short-term memory, and then on to moving it into your long-term memory. So you know the information going forward from there. Then it's a matter of just relying on your recall capability, so that the information can be easily recalled especially when you're passing your certification exams there. Okay. All right. I think we are set, ready to rock and roll here on all of the broadcasts, the live broadcasts on YouTube. Still waiting on a couple of students here. Not really sure why they have not joined the party as of yet, but they know what time we start, so we're going to get on into it. All right, let's see here, guys. Any comments, any issues you had with your homework, your labs, or anything like that? We can go ahead and address those. All right, so all good, I guess. Let's get on into it here. Now, up until this point, we have, we've introduced several different tools that are available to assist in doing the penetration testing. Yesterday, we looked at a couple of tools more from a networking and an individual host attack perspective. Now we're going to look at attack tools and attack methodology that really addresses the enterprise as a whole. And it doesn't really matter the type of enterprise, the size of enterprise that we're actually dealing with here. The attack methodology, attack tools are pretty much the same. It's just a matter of different host machines, different number of attack vectors that are available to us when we start planning an enterprise-wide attack. Now, I've mentioned to you a couple of times the first focus when we begin a penetration test, of course, is to identify and enumerate all of the available targets, and then do our vulnerability assessment function so that we discover where the exploitable vulnerabilities on those targets are, and then select the proper tool suites that allow us to target those individual host machines. Of course, on desktop systems or user-based machines, there are different vulnerabilities that may be available there, different tool suites that we use to attack those. And then, for instance, yesterday afternoon, we concentrated on the websites and the web servers. And I told you about a couple of different, very specific attack vectors there. Things like your command insertion, inserting SQL commands, or any of your other query-based command functions that we have in the network environment in general. We also looked at things like your directory traversal, perhaps being able to sneak directory positioning through, even in a website, to be able to position ourselves, for instance, up to the root directory level, and find all of the administrative level and the root directory level functions that may be exposed there. As I told you in all of the other types of attack vectors that we talked about, the largest area that we see that exploits vulnerabilities is misconfiguration, no doubt about it. That's true as far as setting up, the IAM services, the identity and access management services, the directory services for an environment, of course, Windows, that's Active Directory services, and the other operating systems is simply referred to as LDAP, Lightweight Directory Access Protocol, or directory services there, implemented in different ways by way of different operating systems, different network environments. But the concept is the same. The directory there stores the subjects and the objects that we talked about. The subjects, of course, are individual user profiles, group profiles, service profiles, and then the objects are anything that has to do with the network: files, folders, directories, servers, database engines, the network itself. And then, of course, the directory services, the LDAP services there, assigns access and permissions to a subject for access and permission to an object. So that's a large target. If I can gain information and access to those directory services, that gives me a wealth of information, allows me things such as being able to elevate privileges, horizontal escalation or elevation, or vertical escalation, either one. Here are some objectives that we will entertain in this particular module here. And again, it's attacking systems more from an enterprise-wide mode, including the enterprise network there as well. Sniffing network traffic. We talked about the network sniffing, the protocol analyzation tools like Wireshark or TCP dump. We also spoke quite a bit about, and you guys actually used it in a couple of labs, the Nmap scan utility. Now you start really getting the power out of Nmap when you incorporate the Nmap scripting engine, allowing me to do multiple scans with a singular script. And that also plays into what I've been telling you guys about several times about using the power of the scripts and the scripting engines in general, not just Nmap, but any of the scripting languages, to automate processes. Because in many cases, if you are going to launch an attack against one host machine in a network, more than likely you're going to want to do that same type of probing and attack on multiple machines. So rather than, again, typing the same old commands, one after the other, well, script it. And especially when using tools like Nmap, your network mapper. There are several other types of tool suites, and we spoke about most of these already. A couple of them now you'll use going forward in the class in other lab exercises. I talked about the Netcat scripting engine utility. Very simple to get it loaded onto a host machine and write some very powerful scripts. I talked about the password cracking utilities, and this is one that I mentioned out specifically yesterday, but it's just one. John the Ripper is a very well-known password cracking utility. I'll give you guys a link to that. You can download all the source code for this. It is it's very flexible, as a matter of fact, on what you can do, how you can actually configure it. There's the link to the source code there on the GitHub site. And I remember I told you guys the other day as well, the this open source code that is housed either in the GitHub site or the SourceForge site, I'll tell you what, the programmers there are really on their game, and they provide superb documentation for all of the, the code snippets that they have available for you to download there. Now, in addition to that particular site, I want to show you as well. There we go. Is this the one? I believe this is the, again, I have students all the time send me these links to these particular utilities and tools to use. Let me see if this is the right one. Nope, this is not the guy that I'm talking about. Maybe it's, well, maybe this guy right here. I don't know. It was about a half an hour, so I think this is probably it right here. We shall see here shortly. Nope, that's not the right guy. I'll try to find the YouTube, and I'll actually find the email the student sent to me. But it's a really good YouTube video that shows, and it's about a 20-minute, 30-minute or so introduction on how to use it. Now, here's a good link on from the CISA site, the Gov site here. I'll give you a link on that as well. But I will find the YouTube video that I was talking about here and share that with you. It's really good. Like I say, John the Ripper's, but one of those. There's another one called Kane. There is a couple of other utilities that I've used. One called Medusa, another one called THC Hydra. And all of those password cracking utilities they're multi-purpose. You can do the straight brute force password cracking functions. They will provide you ability of doing the dictionary type password cracking and even the rainbow table type password cracking things. Now, doing online password cracking has become much more difficult because, as I was telling you guys, I guess the day before yesterday, the network engineers have gotten much more savvy, and after 2 or 3 or 5 invalid attempts, they just lock the workstations down. So it sort of cuts much of the functionality here out. Now, there are some things that I can do and use these things to sort of get around that cutting off the, disabling the workstation there. But those utilities allow me to set up the password cracking functions there. We talked yesterday about the SQL function, doing SQL injection. There's actually a lab that goes along with this lesson that you actually entertain and do the SQL interactive injection as one of the lab exercises. So you actually get your hands on that. So these are but a few of the things that we're going to talk about in this particular module here. Now, network-based attacks, of course, have to be planned very, very well. They are, yeah, you have to plan the attacks and entertain many of the different functions and the different subsets and subsegments, if you will, in a particular network too. And understand now the way that networks are configured nowadays, they just about every, especially medium to large size organizations anyway, they are beginning to incorporate virtualization in-house using hypervisors, much more efficient utilization of existing server class machines, server space, setting up virtual machines in-house, the containerization environment that we talked about yesterday. Many organizations as well, again, the larger organizations are the ones that are they have taken in-house also the management of, for instance, digital certificates. So encrypting and protecting servers and web services and print services and with digital certificates. So using the secure protocols, HTTPS, the secure shell running FTP, thing like that. And many of those require the installation of digital certificates. It does give you additional layers of encapsulation and wrapping. So those are the things we want to probe and look for when we start setting up our penetration testing. Because, if people are implementing good, strong encryption algorithms, well, we don't need to waste time trying to decrypt those things unless it is some of the low level encryption algorithms like we looked at yesterday that have already been cracked, and we can get the code down for free to do that. Now, remember, I told you with enough computing power and time on your hands, you can crack any encryption, but it may take 100 years, So if you find that when you're doing your reconnaissance and setting up the penetration test, if you find those security wrappers already implemented in an environment, don't waste your time. Move on to the more vulnerable targets there. Okay. There are certain things that we can do at the network level that are designed for fooling or evading certain things like firewalls or intrusion detection systems, intrusion prevention systems. That's where we will utilize some of the additional network oriented software applications that allow us to put together individual attack packets right down to the individual packet level in a network communication session. Things I mentioned 2 days ago, we talked about the concept called firewalking, crafting data frames and packets that are designed to bypass firewalls. Same thing with proxy services and intrusion detection systems, things like that. So, and again, this stuff is simplified, but it's not easy. It gets complicated if indeed you make it so, and it is very complex. So you have to understand how the tools work and the multifaceted setup required to launch some of these different types of attacks. Okay. There are many different types of network attacks that we can, excuse me, that we can launch. There are those attacks that are more, like I was talking about the other day, more passive things like passive reconnaissance, paying attention, observation, things like that, and even using some passive tools to monitor from afar network traffic and systems. Tools like Wireshark, capturing data frames and packets. We're not interacting directly with individuals inside the network or even perhaps some of the network host machines themselves. I'm just monitoring traffic from afar, either in a wired connection or a wireless connection. Either will work, and I can capture data frames and packets. Okay. Then there are other more active type of network attacks that may require that I have already compromised at least one host machine inside of a network, gained that unauthorized access. Those are called on-path attacks. I am physically resident inside the network there as well. So, based upon the type of network, the configuration of the network, my definition and my recognition of all of the individual attack vectors and all of the idiosyncrasies involved with those attack vectors, that's how I start planning my attacks, both passive and active type of attacks. I spoke briefly about this VLAN hopping thing here over the last couple of days. That's actually taking control of or gaining unauthorized access, for instance, to one of the virtual machines that the companies may be hosting either on premise on their network or in, for instance, their cloud-based environment, evaluating the vulnerabilities in the VM and the VLAN setup, and then taking advantage and exploiting those vulnerabilities, and hopefully in the VLAN hopping environment. Virtual local area networks are set up using switches, the managed multi-layer switches. So a VLAN can, the whole concept, and you guys, this class assumes you already know this. It's assigning, for instance, individual port numbers on a switch to a virtual local area network. And even though I may have, let's see, 40 people physically hooked up to the same physical switch, well, I can further subdivide those into these virtual local area networks, and you do it at the programming level of the switch itself. So even though they are physically attached to the same piece of equipment, they are isolated in their own logical virtual local area network. Isolated and hopefully protected if the security professionals have done their job. But for me as a pen tester, I'm hoping they didn't configure those things properly, because there's some very specific things I can do. Attack one host machine on a virtual local area network, figure and exploit vulnerabilities in that misconfiguration, and jump from one VLAN to another VLAN to another VLAN. And also remember too, on those switches, those new managed multi-layer switches can be daisy chained together in essence. They call it trunking. So I may be able to spread a virtual local area network across 1, 2, 3, 10 different switches, and they could be in different areas on a large campus, for instance. But that VLAN hopping will accommodate me being able to access systems across other virtual local area networks and bridge the gap between those, in essence. We've talked about most of these tools already here. We talked about the network mapper Nmap. We gave some examples, and you guys did some performance-based questions and a lab exercise working with the scripting engine, the Nmap scripting engine. Here's other tools. We mentioned Wireshark. I gave you the link to that. We spoke in passing about Responder. That's a pretty clever tool there. There's actually one of your labs that you actually use the Responder tool for doing some reconnoiter and then pulling information from some of the systems. The in-packet, that's another pretty cleverly designed tool for allowing you to do network-oriented types of attacks. There is embedded in the Metasploit utility. I gave you guys a link to that the other day. There is it's sort of a database and a directory collection. It's called the Meterpreter. Down inside of that, there is also some very interesting code piece of it here called MSF Venom. Let me give you guys a link to that utility there as well. That's pretty interesting tool suite there. Being able to in essence poison and introduce payloads inside of a network connection and deliver the venomous, poisonous payloads. It is also, you'll see, a Linux-based tool suite. The thing I'll give you this link on this page here. It gives you right on the front page some of the examples I was talking about of the documentation that these tool builders actually built right into the tool suite itself. Okay, so that shows you information about all of the available options there and examples of what the options actually do. Now, once again, these are Linux-based tools. So you will have to understand the Linux syntax, okay, in order to use these things properly. So again, I gave you guys the link the other day to the Linux cheat sheet, and the what I use here is my Linux Bible, the Linux for Dummies book you can get from Amazon. Linux is here to stay. It is being more widely adopted now, especially since we have so many cleverly designed Linux distributions that are, all of them are free. And especially now with all of the really slick design looking graphic user interfaces that we see for Linux as well. For all too long, if you were going to drive a Linux or a Unix system, you drove it from the command line interface. And I was telling you guys, I am trying to educate myself more on Linux. I'm not a strong Linux guy at all, but I am going to get the Linux distribution just for personal gratification more than anything. But you need to really beef up your Linux skills. Say it is being much more widely adopted especially even on desktops now. Linux almost owns the server space already, but it's starting to be used a lot on the desktop there as well. I was telling you about the misconfigurations. It's still probably the largest area of attack that in a network environment, one of the largest areas that we need to pay attention to as penetration testers. I spoke about the default credentials that are inherent on every system that comes out of the box. Doesn't matter who the manufacturer is and what type of system it happens to be. All too often, the network engineers and especially the security practitioners, and more especially in large corporations, I find they just don't follow through with that structured, organized concept of basically changing default configurations, hardening the systems in general when they come out of the box, which again is great for we penetration testers, not so good for the security of the organization in general. Just about every system that comes out of the box from every manufacturer has some type of default credential setup that allows you access to the system. Oftentimes, like I showed you guys the other day before yesterday with the routerpasswords.com site, that information is freely available out on the worldwide interweb for all to see. Okay. Another thing, in lots of companies and organizations and even individuals now are beginning to utilize encryption. Encryption also requires a passcode or a passphrase of some sort, some kind of credentials that will allow you to unencrypt and encrypt data. Well, storing those secrets or those encryption credentials in an unsecure format is opening the gates to the ne'er-do-wells. I hope I find those when I'm doing penetration testing. Okay. Even the encryption of highly classified or sensitive data is something that all too often, good for us pen testers again, the information is simply not treated as highly secure information. Okay. I love to find that. I truly do when I start setting up an ethical hack or a penetration test. Some of these on-path attacks here, you'll hear that terminology a bit, on-path attacks. Actually, most of those begin with capturing data, intercepting communications, either between two individual host machines, or sometimes in between application programs by way of the application programming interface. The on-path attack they're talking about here specifically is intercepting data that is being exchanged between two unsuspecting endpoints. Now, these attacks used to be referred to, these on-path attacks like that, used to be referred to as man-in-the-middle attacks. They've sort of gotten away from that particular terminology, but it still applies. I position myself in the middle of two endpoints that are communicating, and they think directly with one another. I utilize things such as overlaying or spoofing things like MAC addresses or IP addresses even. So I spoof, for instance, my MAC address in what would appear to be a MAC address of a gateway appliance. Because if you got two different people talking in two different network segments, then their traffic goes through some gateway, some router gateway device that overlays their basically a template, as it were, subnet mask. I mean, that's the term, but a template that determines which area of the subnet they actually belong to. If they're talking either outside of the autonomous network, or if they're talking within the same network in different subsegments or subnets in the environment, well, the gateway device is what determines where to deliver those data to. So if I use tools like Wireshark or Responder or a couple of the other tool suites that we've talked about this week, I can capture those data frames, very rapidly change and overlay and spoof the addressing information so that now it appears that my system is the gateway device. So rather than them going through the gateway, now all of that traffic is coming through me. So I can change the communication session, the content of the messaging to whatever I want it to say. Netcat is a tool that is used for setting up those on-path attacks. There's a couple of other tool suites out there that are available that I can do that same spoofing, poisoning, overlay kind of functionality, and basically take control of the session and redirect traffic wherever and whenever I want it to go. See? The digital certificates I was talking about, that is for the longest time, that was almost a 100% commercial entity that actually created and managed and sold, in essence, the digital certificates to companies and individuals. Now we're seeing lots of, especially larger organizations, have begun now to take that whole management process in-house. So they set up their own what's called a certificate authority to manage, create, and track the certificates. The certificates are then installed, say, on web servers or application servers or even on individual host computer systems. And always, and they call it public key infrastructure, PKI. You guys should be aware of this. And there's a public key and a private key, two keys. So, when you visit for instance, a website, the very first thing that occurs is the website itself sends down a copy to your browser with the digital certificate, which has the public key embedded in it. Private key stays up on the server, and then your browser does a couple of interesting things. It does it so rapidly you don't really see it, but it validates the digital certificate somewhere out on the worldwide web. There's a server out there somewhere that says, "Yep, this is a good certificate. You can trust it." And then the couple of things happen in your browser. For most of the modern browsers, your address line turns green. The padlock icon on your browser shows that it's locked, and then the public key you have and the private key up on the server, they do a real-time negotiation of what the encryption algorithm is going to be used, usually for that session alone. And again, it all happens so rapidly you don't really see it occur. But lots of large companies now, rather than going outside to a commercial entity to purchase the digital certificates, they're managing the whole thing themselves in-house. There's several different tool suites. I mentioned the other two, the Impacket and the Crack Map Exec, this guy down here. Those are tool suites that we utilize to form certain types of attacks and try to crack these credentials, try to find the vulnerabilities and the weaknesses in that exchange, even up into the point of forging certificates under the guise of being the certificate authority that issued the original digital certificate, and sort of overlaying those things into the network environment. And then in even some cases, being able to find where the credentials are actually stored if they're not stored in a very secure environment, you see. If the private key that is associated with a digital certificate is ever exposed, well, that whole house of cards falls apart, because that private key is the chain of trust. That's where the trust relationship begins. That everything down line from that is dependent upon that private key for the encryption algorithms, everything else. I told you before, I'll tell you again, misconfiguration is the largest vulnerability in any organization. And I'm talking about misconfiguration across the entire width and breadth of the organization in general. Setting up very weak or not well managed password authorities, allowing users to use the same password for long periods of time without changing it, without forcing the change, allowing users to reuse passwords over a long period of time. All of those things are, weak password policies, misconfigured systems that are not hardened, changing default configurations. A lot of folks don't realize down underneath the covers in almost all computer systems, and I'm talking about down at the BIOS level, you can set an administrative level password credentials that are required in order for anybody to change the BIOS. Most network engineers just simply don't do it. So if you can gain access to a system, elevate privileges on however you were able to hack into that device, you get down and take 100% complete control at almost the firmware level of the computer systems themselves. Okay? And there's several of the tool suites you've already talked about that have script code and attack type code designed to do just that. Okay. So looking for those misconfigurations, taking advantage and exploiting those vulnerabilities is a large area of concern when we start setting up a penetration test. And many of these attack tool suites that we've already talked about here are used for doing just those very things. Okay? Now the VLAN's a very interesting concept here. The virtual local area networking, it's actually relatively new. I'm going to give you guys a couple of links here. I got one tutorial that is online, a web-based tutorial, and then I've got a really good YouTube video. You really need to learn about VLANs. if you don't already know about it. Okay. Um, Let me find the link. It should pop up and show that I've already got it listed here as far as the online VLAN, and then I'll give you a link to the, there it is right there, Geeks for Geeks. This is in my opinion, one of the best online VLAN tutorials I've ever seen. I really like the cats at Geeks for Geeks. They really know their stuff. And then I have this guy here as well on the YouTube video. Where is he? Where is he? Is this it? I don't think that is his link here. I'll tell you when I first hear him start talking, I'll be able to. That's him. That's him. Yep, you'll love this. Now, VLANs are constructed, as I was telling you guys, with these managed multi-layer switches. When we set up a virtual local area network, like I was saying, we assign, say, the first 5 ports on a switch, and I might call that VLAN 10. Okay? The next 5 or 10 ports, I might call it VLAN 20. So just like a physical local area network, if I want a workstation in VLAN 10 to be able to communicate directly with the workstation in VLAN 20, well, if they're separated as far as the VLAN definitions, they can't talk directly. They have to go by way of a router gateway appliance, just like if I'd set up different subnet addresses or subsegments in the network. Same concept here in the VLANs. Well, if I and there's actually code that I can do and a couple of different methods I can use to sort of flood a VLAN. It's called a MAC flood. We'll get to that later on as well, but I can flood the switch there and turn it into basically an old hub, a large broadcast domain, and then have access to every system on every port. But there's a couple of other methods that I can use with that VLAN hopping as well. Um, if I'm going from one VLAN to another VLAN, and for instance, a different switch, I was talking about trunking those switches together. Well, the way that I constructed my packet, they call it double tagging. I use 2 different tags that identify 2 different switches in the same packet. And it sort of confuses the programming down at the switch level itself. So it allows me to take advantage of those vulnerabilities, exploit those, and move from one VLAN to another VLAN to another VLAN, even if indeed the VLAN is spread across multiple switches that are trunked together. Okay. Now understand too, they layer 3 or multi-layer switches, they call it. They're not like our old hub devices where anytime anybody that was plugged into any of the ports broadcast, requested a communication, that packet was broadcast to every port on the entire hub. Well, it's not like the new managed switches. They use an internal table, a data table that matches up the MAC address of whatever computer is plugged in to the port number it's plugged into. And it maintains that table. Well, that table is finite. It's not, you can't stretch it. If you got a 24 port switch, the table will handle 24 entries. There's a script program that I can run, if I can compromise one of those ports, plug up my system one of those ports, then I can run a program that overwhelms that table by saying, well, here's MAC addresses for port 10, 20, 30, 10, 11, 12, whatever, fill up all the ports, and it confuses the hub or it confuses the switch. It's called a MAC flooding attack. So it then reverts back to the old way of being just one large broadcast domain. So now I can read all of the traffic that is being broadcast on any of those, and I can also manipulate that to do the VLAN hopping from one host to another host to another VLAN to another VLAN, even on to those trunk switches that I was talking about, trunking those things together. Okay. Now there are certain things that I can do, or that these security engineers can do to remediate that kind of thing, mitigate those types of attacks. I can only use specific ports that are dedicated as trunk ports on a switch and not create my own. That's one of the things. Any of the switch ports that are not already assigned to a virtual local area network, they are by default assigned to VLAN 1, and that's the default across all of these new managed layer 3 multi-layer switches. I set up holder VLANs. Like on switch 1, I'll set up VLAN 90. And any unassigned ports, I'll assign them to VLAN 90. They're no longer assigned to the default VLAN 1. On switch number 2, I'll set up VLAN 80. Switch number 3, I'll set up VLAN 70. So placeholders for all of the unassigned ports, well, that negates this VLAN hopping, this VLAN escape kind of thing, you see. But those are the kind of things that I want to probe for when I'm looking at these guys as a pen test, and perhaps even launching that MAC flooding type of attack to overwhelm that switches table and make it act just like a large broadcast domain hub. Okay. So that gives me a lot of flexibility as far as moving among the systems. Okay. So now I've mentioned to you a couple of times already about setting up inside the DMZ, the demilitarized zone in that extra net area I was talking about. In order to do that, we will find that there may be a requirement for me to have one individual host machine inside server class machines typically. And those are the ones I was talking about where we have external management companies that, for instance, are managing my building automation systems, things like that. Well, those hosts are multi-homed in that they are a member of my network, but they also need to be a member of the management company's network as well. Okay. That's one instance of that where we set those multi-home systems up. Sometimes we may set the systems up for doing security kind of functions, fail-safe kind of functions, or setting up, for instance, an array of clustered servers for load balancing functions, that kind of thing there. So we also find that in lots of cases, those multi-home servers are, like I was talking about, the web servers, the extranet web servers, proxy services that are utilized to enhance the functionality, for instance, for some old legacy systems, firewalls, intrusion detection systems, things like that, or the firewalls themselves. We're beginning to see a lot now in the industry in general. These new devices that are sort of aggregating into a singular box, multiple device functionality, firewall, the gateway, the router device, the switch, all crammed into a singular appliance. And I think, especially the closer we begin to get to adopting the version 6 IP addressing and the Internet 2, whatever that's going to be, I think we're going to see a lot more of that convergence and the aggregation of those multiple functions inside of a singular device. But those are all multi-homed host types of appliances there. Right? Those are large targets. And those are also ones that network engineers, mainly because they don't really understand the whole functionality of those things, they're simply not configuring those properly, which is great, again, for us penetration testers. Okay. Now, these relay or relay types of attacks, I mentioned a couple of these the other day when we were talking about the cross-site request forgery and cross-site scripting kind of sites. Basically, intercepting information that is going between two different computer systems, oftentimes changing that data in that man in the middle concept I talked about. Or there are certain attacks, like, for instance, in the Windows environment. Windows domain environment in general is pretty much reliant upon a service. It's called a AAA compliant service called Kerberos. Kerberos is referred to as a ticket granting ticketing system. Here's the way it works by default. So you go to log into a Windows domain, you basically present your, here's my ticket, here's my credentials, and I want you to validate my credentials and allow me to gain access into this particular network. So it's presented to what's called the Key Distribution Center, the KDC. KDC validates your credentials. It can, and many of them do, require multi-factor authentication, user ID, password, fingerprint, facial scan, whatever. So they, in essence, punch your ticket, and that says, well, you are now allowed into the front door. What they do is they create a hash message digest, same concept as a cookie that we talked about yesterday from the website. And it may be even that same kind of thing as well. But it basically creates that hash copy of your validated credentials and stores that down on your client machine. Now, the nature of that beast as well is if I then want to access any of the other subsystems inside that network, I can present that hash copy to those. And if indeed the network is set up for single sign-on, okay, it will just validate that hash and say, yep, you've already been validated, so you have access to whatever the subsystem may happen to be. Learning management system, web server, database engine, whatever it might happen to be. If I then, as a hacker and attacker, and there's a lot of script code that shows you how to do this, if I can steal that credential, that hash, much the same concept as stealing the cookie from the web, web cache there, I don't have to know the password. If I can associate that with a user ID, I just pass that hash copy to the next service in line. It's already been validated by the Key Distribution Center. So it says, oh, okay, yep, you're a validated user. Here you go. Okay. Pass the hash, pass the ticket. Okay. Those are both examples of what we call on-path attacks. Or I can, intercept that communication between two endpoints, spoof the addresses, make them think anyway that I'm their gateway appliance there, because spoofing MAC addresses, things like that. Now, intrusion detection, intrusion prevention systems, a couple of interesting pieces of relatively new security hardware and software. Um, just like many of the other security mechanisms that we've seen installed in networks, these guys are largely dependent upon pattern recognition, signatures, as it were. Many of them operate much the same as the most of your older legacy firewalls do, processing, in essence, an access control list, or sending packets through a filter of some sort. IDS systems are passive by nature in that they are, they're designed to recognize some type of anomaly and raise a flag. They're not really designed to do anything about the intrusion other than alert you that, the intrusion is there. Whereas intrusion prevention systems, on the other hand, they're like the difference between a security guard or a security monitor and an armed security guard. The security monitor, the IDS, says, hey, we're being robbed. The security guard, the armed IPS, the intrusion prevention system, says, hey, we're being robbed and up against the wall, fool. So more of an active kind of function that can do something about the intrusion there. Okay. There are several different evasion techniques and software that allow me to intercept information going to and from an IDS or an IPS system, utilize some type of packet crafting software that allows me to craft these very cleverly designed payloads, presenting TCP flags, things like that, that are designed to evade the functionality of the IDS systems and the IPS system, and even the firewall type system, proxy services, and so on. So there's several different pieces of software out there that allow me to do that interception, packet crafting, creating the malicious payloads to these devices that are designed to evade them, to get around them. Same concept I talked about yesterday. We talked about firewalking, crafting the packets in such a way that it confuses the firewall. It doesn't know what to do with this with the payload you presented to it. So I'm just hoping that its default is to, yep, let it go on through. If it doesn't meet any of my filters, I don't know what to do with it. Let it go on through. We'll see. There's one such attack it's referred to. I think I mentioned to you guys a couple of days ago. It's called a Christmas tree attack. And it's designed, they call it a Christmas tree attack because the very unorthodox selection and combinations of these TCP flags, they say it lights firewall up like a Christmas tree. So an evasive technique there, firewalking, they call it too. So, all right, let me see right quick if I want to have you guys do this right now, or are we going to wait on it? Um, had to log off and log back on here, so I'll have to get to this right quick. You guys bear with me just a sec here. I think the less or the module quiz here is very, very short. We may just go ahead and bypass that altogether and move on to the next lesson lecture here. I do have a Yep, there's the network, the live lab I'm gonna have you guys do there. That is using the network sniffer, the Wireshark tool. So I'm gonna have you guys doing that, and also Netcat. Um, some of these we may do during the class time today. Yeah, that's a 10 quick questions there. Tell you what, I want you guys to go ahead and do that right now. Now, any of you folks that are dialed in on our YouTube channel, of course, you will not be able to participate in this quiz, and it is timed. I'm going to set up a timer for the folks here. The way we do this is they take the lesson review quiz. These are short and sweet, and then they post their scores. Everybody posts their scores in the chat box here, because I want everybody to feel proud of those scores, whatever they might happen to be. Doesn't matter. It's all good news. So you guys that are, if you happen to be dialed in on YouTube, just hang with us. It's going to be very short and sweet. I'm going to set a timer for a quick 10 minutes. And you folks in the classroom, hunker down on this. Good luck on it. And I look forward to seeing everybody's scores here in the chat box. Go for it. And we'll be right back here and pick right up where we left off. All righty. Well done, gentlemen, on your quiz scores there. Very, very well done, as a matter of fact. And remember, guys, I was telling you before, the repetition on this stuff is what really, really drives it home. Even if you score like you guys are doing 90, 100% on these things, do it again, take that again, and it will really drive that stuff home into your long-term memory. So you know it, you know the information for sure. Okay. All right, let's go ahead and shut this sucker down here now, and we'll dive right on back into our lecture here. All right, let's clear that out, pull back up the presentation here, and continue on. Now, there are certain types of attacks. There are certain types of things that we will do when we're planning these enterprise level attacks. I've mentioned several times already that many of the weaknesses that we find are configuration weaknesses, rules not being enforced properly, especially as it relates to the authentication of users when they go to try to gain access to the network themselves. The authentication attacks come in a number of ways. They're pretty much concentrated on attacking the LDAP services, the directory services there. A quick refresher, remember the directory is what houses the subjects and the objects, the definitions therein. The directory is where we assign access and permissions to an individual user profile, a group profile, or service profile to gain the appropriate access and permissions to network objects, and the network being one of those itself. There are a handful of very, very effective script programs out there. I mentioned several of the password cracking type of programs. And those are not only just for cracking passwords, they have other functionality built into those as well. I mentioned the ticket granting ticketing system environment, the pass the hash or the pass the ticket attack. There is software that's wrapped up in many, or software modules that are wrapped up in many of those password cracking kind of functions that provide that same kind of functionality there. Stealing the hash copy in the ticket granting ticketing system and passing that hash as the credential. Don't have to unencrypt the information. The system's already been primed, as it were, to, if I pass a hashed copy, which is an encrypted copy of a password credential, along with the proper user ID that it's associated with, pass the hash, pass the ticket. The system's already validated that information. Okay. There are several different vulnerabilities and weaknesses that we can exploit along those same lines. And the majority of those have to do with misconfigurations and network engineers, operations managers, things like that, simply not understanding how to properly lock down the credential authentication mechanism on the different levels of systems that they may be managing. Okay. So a whole host of different authentication types of attacks that are utilized now, and the authentication attacks are basically targeted towards the different levels of authentication that are implemented by different network engineers and different systems. Now, when we start breaking down the authentication, multi-factor authentication methodology, it basically originally, we only heard about three of these. There was knowledge base, something user IDs, passwords, PIN codes, things like that. So there's password cracking utilities there that I can utilize, try to figure out what the password might happen to be. There's something you have that is ownership based, a key fob or a swipe card, a military cat's your CAC. That's something you have. Okay. Then we have something you are. That's where you start getting into biometrics, fingerprints, thumbprints, palm prints, facial recognition, things like that. And then over the last couple of, I don't know, 3-4 years or so, we started getting into location-based geofencing, location-based types of authentication factors, somewhere you are, physical location. Almost all of your, especially the portable appliances, your mobile phones, your tablets, your phablet devices, almost every one of those things now has some type of GPS type circuitry. It's also being utilized by these new systems called indoor positioning satellite systems, or indoor positioning systems. But it's the same circuitry. It gives you that longitude, latitude, geolocation function. So they set up these predefined geo fences, in essence. And as long as you're within that predefined coordinates when you try to log in, well, that factor is also validated as well. And then we get into, and for me and many other security professionals, this seems like just an enhancement, an extension on the third level, the biometrics, something you do. I understand the difference. I truly do. And you do as well. Like the way you sign your name, not the signature itself, but the pattern, the swipe pattern, facial recognitions, expressions, things like that. So something you do. And the different types of attacks that are facilitated with these authentication methods there, if you can steal credentials, great. That gives you the information you need to satisfy the multi-factor authentication thing. Stealing credentials or figuring the credentials out, stealing the hashes, like I was talking about, the ticket, the punched ticket, as it were, that was utilized in order to gain that unauthorized access. Okay? That's yet another method of being able to jump in and take advantage of a specific environment, steal credentials, and log in as somebody else, thus assuming whatever their role might happen to be. Uh, See, we've had a audit student join the party here. Kulan, I want to welcome you to the presentation here, and I want you to feel free to participate. If you have any questions that you would like to ask while we're doing the lecture here, feel free to jump in and ask those. I welcome those of all of my regular students and the audit students as well. And let me give you my email address too while I'm thinking about it. If you think of anything that you would like to ask about after the fact, you feel free to drop me an email. And I promise you, I always answer my emails. So again, welcome, enjoy your time, and I hope you get out of it something that will lead you to join us later on. Multi-factor authentication. This multi-factor authentication fatigue, they call it, MFA fatigue. I know you guys have encountered this. Okay. Remember back, and this usually was a thing that they used in the very original implementation of what was called Microsoft Land Manager, LM, NTLM, I think they called it. They would ask you these leading questions. Select your question from the drop-down list box and provide your answer. What was the name of your first pet? There's the answer. What is the middle name of your closest sibling? There's the answer. Okay. Where did you graduate high school? There's the answer. Okay. Well, they realized pretty quickly that what people were doing when they were setting up and getting those questions were same kind of stuff that these folks were posting on their Facebook accounts or their TikTok or their X accounts, whatever, their Pinterest accounts, and so on. So the ne'er-do-wells, the thieves, thugs, and malcontents jumped on that very quickly and just started browsing through I call them the social engineering websites like Facebook, and figuring out the answers to those questions. Also, people got pretty much tired of trying to set up subscriptions or whatever on sites and being required to choose these 3 or 4 or 5 questions and answers. Just ludicrous there. So that sort of went by the wayside, and in my opinion, rightly so. People just don't, they're not into that. But these types of authentication attacks here as well lend to, or the authentication methods lend to those types of attacks, especially if they are not implemented properly. That's what I look for as a penetration tester. Now, several of these I've already mentioned here. There's responder, I talked about Hydra. Hydra now is called THC Hydra. John the Ripper. We looked at Bloodhound over the last couple of days. There's Medusa. That is a multi-headed password cracking attack suite. We looked at Responder. Gave you guys the links to that. There's the old trusty Burp Suite. These are all tools that I utilize in order to attempt to set up and then implement these authentication types of attacks. Responder is one that is that's used a lot, and it's sort of a wide cast net because it encompasses several different types of attacks that can be launched against the credential type of attacks there. And now that I think about it, I don't believe I gave you guys the link to the responder page yesterday. Maybe I did. I give these things out. I just don't remember. Well, I see it's highlighted, but there's the link to all the source code for the responder utility there. Pretty widespread, wide-reaching there. It is. There's a couple of the things there that are targeted towards the LAN manager weaknesses that I talked about in the especially in older versions of the Microsoft operating environment there. So that concentrates on trying to crack and hack those things. Again, let's see, 1, 2, 3, 4, 5 of these are concentrated on the on-path password cracking type of attacks. And then there's at least 2 of them there, well, 3 of those there that are utilized for setting up all different types of attacks there. The Burp Suite also, that's that is one that is sort of concentrated towards these types of attacks against websites. We talked about that yesterday as well. The multi-factor authentication attacks here are implemented, for instance, by just scrolling through an online automated computer program and just blowing all of these combinations of user IDs and passwords into a particular site, a website, or a client of some sort. Now, I told you earlier, those things are much more difficult to carry out nowadays because network engineers have gotten savvy and they're just locking down the workstation after a limited number of invalid login attempts. But again, there's a couple of ways I can get around. There's one called password spraying, to where I can go down a list of passwords, but don't do more than 3 attempts on the same user ID. Okay, so have passwords and user ID combinations there, and keep it to whatever the minimum on the website might happen to be. So just go down those lists, So there's ways I can sort of fool the lockout kind of functionality that the network engineers have implemented now for those invalid login attempt numbers there. A couple of ways. Pass the hash attack there. That's what I was talking about with I don't have to decrypt or unencrypt a password from the hash copy of it. If I know a hash copy that is matched up with a certain user ID, I just present that to the login credentials or present it to the next subsystem inside of a network where I've already been validated. Okay. Metasploit, Hydra, Medusa. Those are tools that I can use to implement not only the 3 basic password cracking functions, but these pass the hash types of attacks as well. Okay. And also Metasploit and Responder have tool suites involved, or in scripts involved in their tools, that allow me to steal those hashes. And those hashes, when they are sent back down from these, like the ticket granting ticketing system, and stored on a client environment, a client workstation, or even a web browser, well, those guys are really good about figuring out where they're stored in that cache and the naming conventions of them, things like that. Okay. Talked about Kerberos. There's a couple of other types of authentication services there that are utilized for doing that ticket granting kind of function. And all of those can be set up either in their default mode So you log into the front gate or log in through the initial network connectivity, and then all of the other subsystems inside of that greater network. If you want to access those, you have to return to the key distribution center to get your ticket punched, in essence, to get access those other subsystems there. However, those can be set up as well as a single sign-on so that you only get the ticket punched a singular time, and then it is valid then for any of the other subsystems inside the network. Those are the ones I really want to get my hands on when I'm doing pen testing, because I don't have to go through that reauthorization step every time I want to access another subsystem inside the same network. You see, so and again, Kerberos is but one of the ticketing kind of system environments, but it is one that is the default for Windows domains, by the way. And of course, the default is the ticketing kind of thing. Now, in another type of environment, that rather than doing the hash copy of the credentials, you get issued, in essence, a token, as it were. And that token is same concept. It is a pre-validated type of credential environment, but then the token, it gives you access to many resources, and the resource list can be controlled, by the way, on the way that their system is set up. But it's the same kind of thing. The token then is passed around to gain access to many different systems or subsystems inside of a network. Exactly the same concept as the hash copy, except that it's typically not an encrypted kind of thing. Okay. Now, the token also, and just like in the ticket granting ticketing systems, if you get validated as a systems administrator, well, that's sort of like they call it a golden ticket. You have, I mean, that's free range there. You have access to everything inside that environment and some deep level permissions there as well. Okay. So either I can elevate privileges, I can steal, credentials, administrator type of credentials. I can exploit vulnerabilities inside of the weaknesses that are set up in these systems, and elevate that, call it vertical escalation or elevation, where I take on the permissions of administrator. I tell you, it is so simple nowadays, in my experience, rather, to trick somebody out of giving up that information using several different social engineering techniques. Kerberoasting is another method of stealing credentials from a user. Now, you have to have already some access to a domain level account, and preferably if you are able to elevate those privileges by exploiting some vulnerability in the way the systems are set up. These two tools here, Rubius and Mimikatz, are tools that have script level programs embedded in those. Let me give you the link to the Mimikatz. It's very cool. I have it running on my local system here. But that is one that actually allows me to do that elevation there, credential stealing, as it were. This is an excellent beginner's guide here on these. This is one I've had marked for some time, on using the Mimikatz utility. Okay. Open source, free application tool suite that you get, and it steps you right through the tab A slot B kind of environment on setting up the Kerberoasting attack on systems. And remember, almost all of your Windows domain level environments, they use the Kerberos, they call it KDC, the Key Distribution Center, for managing the credentials to get into a particular Windows domain network type of environment. Okay. There's another couple of suites of products there that allow me to elevate privileges, to assign permissions and access to adjacent types of student or individual profiles, group profiles, or service profiles. Now, I was talking about the golden ticket. There is, if you can gain access to an under the covers service account, okay, there is inside of the KDC, there's a service account that is, and even though it's not associated with an individual user, it's the service under the covers in the key distribution center that is responsible for assigning all of the other permissions. That's the true golden ticket there. And just like an individual user profile or a group profile, service profiles, even though normally it's not associated with a human, you are logged into the system as well. So if I can gain access and take control of those service accounts, that's the golden ticket. I have talk about keys to the kingdom. That is it. Okay. So let me see. I've got a couple of links to the golden ticket attack too. I actually had about 3 or 4 of these. Let me see. All right, where is it? That's how to stop it. That's the one I'm talking about right there. This is the one that tells you how it works, how that golden ticket attack works. And for the good guys, it tells them how to guard against it. So knowing how it works and how to guard against it, really good information there. Okay. I think you will like it. And now again, I want you guys to understand on your exam, you're not going to have to know how to set up a golden ticket attack. But again, I'm giving you guys all this additional information because not only do I want you out of the gate to do really well and pass your certification exam, but I also want your toolbox to be loaded up with additional tools. So when you are competing against somebody else for a particular job function, I want you to be ahead of the game. I want you to hit the ground in full sprint mode. So that's the reason that we share all of these additional links and additional tools that you have available there. Just bear that in mind. These aren't Many of these tools are not designed to help you pass the exam, but they are certainly designed to fill up your toolbox with additional tools. Now, LDAP is the protocol, excuse me, that is utilized by, and we're going to be taking our first morning break here shortly, so you guys bear with me. LDAP, Lightweight Directory Access Protocol, is the directory services. I mentioned yesterday and the day before the injection types of attacks. Okay. SQL is the primary focus towards command insertion, command injection, especially by way of websites, either in the input capable fields or as part of the web address, the URL, sneaking in that SQL code. And I gave an example of that SQL select statement yesterday. Well, LDAP is also based upon a query type of language. It has a request to reply query type function built into it. So if I can sneak some LDAP code into one of those input fields or as part of my URL, that is another type of command injection type of attack. And you have to know the syntax of the directory services query language, the command language. Now, think about the ability of being able to present a structured query statement into the directory services of a system, and especially emulating or simulating that request with administrative privileges. That is the keys to the kingdom to the entire system, because in that directory, remember, that's where you have the subjects, the user profiles, the group profiles, or the service profiles, as well as the objects, the files, folders, directories, databases, server class machines, everything, including the network itself, are the objects inside there. And the directory contains the assigned access and permissions for the subjects to access the objects. So if I can extract that information out of the directory, there again, keys to the kingdom on the entire environment itself. Okay. I can even load up the LDAP query mechanism with data that will completely overwhelm the system with more queries that it can handle, thus causing that denial of service or crash type of attack there as well. Okay. All right, folks, tell you what we're going to do. We're going to go ahead right quick now and take our first actual morning break here. I'm going to set you guys up for a quick 15 minutes. That should give you plenty of time to go and grab that quick latrine break, maybe refill that coffee or juice cup. All of you that happen to be listening out on the YouTube broadcast here, you bear with us. We will be right back after this break time, and then we will continue right along, having more fun than you know what to do with. So you guys bear with us here. We shall be. Let me pull the okay, quick break, and we will be right back. All righty, let's do it. See you back shortly. All righty, folks, let's re-engage here. What do you say? Any of you folks out there listening on YouTube, on the YouTube channel, welcome back to the party here. All right, now where we left off, and we mentioned this information before here earlier, there are three basic types of password online, inline password types of attacks that we've mentioned thus far. There's the brute force attack, which is just blowing every conceivable combination of a password that it could ever be, trying to log into a site. Of course, those are typically shut down by 3 invalid login attempts to lock up the workstation kind of thing. Dictionary attack is a little bit different. It still uses an automated program, just blowing passwords, trying to guess passwords, but it is a predefined listing of dictionary terminology that is, commonly used for passwords. An automated program just blows through the passwords, trying to match it up with a user ID. And once again, the invalid login attempts concept will thwart that as well. Even though, like I say, there's the password spraying kind of techniques that can be utilized to sort of bypass that workstation lockup. But it's a predefined listing, typically a text listing. Computer program just blows down through that. And then there's another version of this called a rainbow table attack, where you take this predefined dictionary listing, but go ahead and use your common hashing algorithms to create the hashed or encrypted copy of the passwords, and then just attempt that pass the hash kind of thing. So passing the encrypted versions of these passwords on with matching up with user ID or a whole listing user IDs as well. So all of the password cracking tools that I talked about, Hydra, John the Ripper, Medusa, the one now called Cain, used to be called Cain and Abel, same thing. All of those will allow you to attempt actually sometimes multiple versions of the password cracking attempts there simultaneously. There are certain other programs that are used. Hashcat is one that we've seen uses trying to use the hashed versions or the hashing masking symbol to try to mask or to create a hash copy of a password there as well. Same concept. It's just blowing through these, presenting the hash copies of these rather than the clear text passwords. And it's by the same token there, these things are thwarted by savvy network engineers setting limits on the number of invalid login attempts. This password spraying thing here, this is one method of sort of bypassing those login attempts, using the password, but rather than using multiple passwords for the same user ID, use the same passwords for multiple user IDs, thus bypassing some of that workstation lock, you see. So it's just sort of the inverse of that password spraying there. It is yet still another brute force kind of attempt, but from the alternate side, and sort of bypass that account lockout kind of thing there. This is yet another brute force type of attack. Call it credential stuffing. Now, very, very low success rates on these things. Once again, because of the lockout, mechanism that most of your network engineers have now begun to implement. So it's just a different method of same kind of brute force type of attack there. But again, very, very low success rate on those because of the lockout functionality there. Now there's a couple of different methods that are utilized for sharing credentials across sometimes multiple sites that are in some way associated with one another, or sites that they have this thing that's called a transient trust relationship. For instance, and again, I know you guys have encountered it before. You go to a website and it says, well, you can log in the website with your credentials here, or you can use your LinkedIn credentials, or you can use your Facebook credentials, that kind of thing. That's referred to as shared identification there, or transient relationships, transient trust relationships, things like that. Some of your websites that implement this thing in some cases are competitors, which I find a bit disturbing. I've told you about that before. There's two different approaches here that are used, for instance, with the likes of Facebook and LinkedIn and Gmail and even Microsoft in some situations. They use a under the covers methodology. It's called open identification or open authentication. Okay. Um, these are oftentimes used, the credentials that are shared across the boundaries on different providers there. If they are stolen, well, that also gives you access to all of the other accounts as well. So, stealing those credentials either off of a client login attempt, or if you can, I was talking about that passing of the token. Once I have federated identification in play, once I validate my credentials in one site identity provider, then those credentials, it's tokenized is the term they call it. And then if I want to log into any of the others, that token is just passed down the line without me having to re-enter those credentials in some cases. Well, if I can steal that token and the token is still in play and still valid, I can use that as well to log into any of the associate sites there as well. And doing that, I can implement those same kinds of attacks that we talked about yesterday when I was referring to stealing of credentials inline real time. Cross-site request forgery, server-side request forgery types of attacks. And in essence, I'm just passing those pre-validated tokens of the credentials that were validated by a completely different site that has some of that federated identification transient trust relationship with all of these adjacent sites. Okay. So that's why it's so very important that those credentials from a security perspective are highly, highly protected. Many times, and good for we penetration testers, they simply are not. Those credentials are they just treat them willy-nilly. They don't treat those as highly secure components that need to be highly protected. Good for us, really good for us. This is a markup language. It's an XML derivative. Same structure as an XML document called SAML, Security Assertion Markup Language. SAML is a markup language that's used by these identity providers I was talking about, and then accomplishes that transient trust relationship among sometimes competing technology or systems, sometimes competing websites, competing providers. That's the scary part where I was talking about these competitors now are all playing by the same rules. And the SAML markup language is the language that is tags up this information and sends it across typically an HTTPS network connection in very secure mode, and presents these predefined credentials to and from the identity provider, and then any downline or adjacent service providers will also use those same validated credentials as well. SAML is a derivative of extensible markup language XML, and intercepting that information there. If I can intercept that off of a network connection, well, I can use that data either for dynamically logging into a site or replaying a session later on down the line. So that's yet another type of attack. And I was talking about the links that my students have sent me. See if I can find this one here. Had a student sent me a link, and I don't think that I saved it. Let's see if I can find it right quick. Well, there's the cheat sheet from OWASP. That's not the link I'm looking for. There it is. That's the one from Medium. Yep. Yep. That's good stuff right there. talking about how the security assertion markup language works. And they also give a couple of examples of how it can be used um, uh, for attacks. Okay. And now that actually gave you an example of the cross-site providers there when that page popped up there wanting me to log into this thing. So this is a really good link here that shows you how this thing works and how you can actually defend against those types of SAML attacks. Really good stuff there. So I'll make sure I mark that this time so I hadn't got to look for it next time. So that's that part of the attack methodology there. Now, let me check right quick and see if I want you guys to do the inline lesson review here on that one. Yep, 10 more questions there. I tell you what, we're going to belay the lesson review for now. I do want to go ahead and finish up this lesson before our lunch break. Yep, we'll be able to do that. And then the checkpoint review at the last of it sort of encompasses all of the individual module level quiz stuff. So we'll just wait on that and do that all at one time before we take our lunch break here. Now, the things that we just looked at there are more for the network-wide type of attacks, and some of the attack suites of products that are available there for doing those network enterprise level attacks. Now we're going to start drilling down a little bit deeper into very specific individual host-based attacks. And whereas the last couple of days we've been giving you baseline information on these types of attacks, here we're going to actually look into actually setting up a couple of those. There's a whole host of different types of attacks that we target towards individual host machines. We spoke specifically about some of the injection types of attacks, LDAP injection, SQL injection. We talked about, for instance, using some of the package creation tools, creating the malicious payloads and data frames and packets, injecting those into conversations. And you can do that injection. I'm talking about the packet injection, not the command injection. But you can create these specific malicious payload packets and inject those right into the middle of a conversation, either with a wired connection, if indeed you are hardwired into a particular environment, or with a wireless connection using the tools that we looked at the second day, the Aircrack NG tool suites of products. There's also other types of attacks that I can do, and some of these have to do with changing log information. Now, while we are doing penetration testing, it's very important that we include methodology that allows us basically to cover our tracks. Okay, you want to fly under the radar as much as you possibly can while you're doing the penetration testing, and there are several different ways to do that. Now, bear in mind, if you're going to be corrupting any logs, system logs, and every system in a network environment, no matter what it is, generates some type of log. And those logs will indeed track your activity while you're doing the penetration testing. Okay. So, if I gain, say, elevated privileges as an administrator into a system, and then I want to go in and change the log entry so that it hides that activity that I did when I elevated my privileges, people would think, well, let's just go in and delete those log entries, because as an administrator, you can do that. Well, the problem with that is that it's a big old glowing red flag because you've got a whole big chunk of a log entry that's just missing. There's better ways. There are, me personally, I would go in and change the date and time stamps on logs so that it reorganizes the logs. Okay. So all of my activity that I did this afternoon actually would show up as having occurred 3 weeks ago. Maybe they're not looking for anything 3 weeks ago. Okay. So that's one thing that you might do as far as rearranging the order of the logs. There's also, in the Linux-based environment, and you guys got Linux experience, probably aware of this, there is a command called shred, S-H-R-E-D. Not in all Linux distros, but a lot of them. but it actually corrupts the log or any text-based information. It's still there, but it's corrupted. It's unreadable. You can't tell what it is. So that's, in my opinion, a better way of tampering with the logs and hiding activity rather than just erasing a whole bunch of log entries and leaving that big bare hole there in the log, the deleted log function. There's also all kinds of different attacks that we can do on individual host machines. Installing new shell script languages on the machines, being able to, they call it shell escape, escaping from the primary shell editors and shell programs, sort of coloring outside the lines and using other shell-based script languages against the one that's primary on the system themselves. Changing information, inserting malicious payloads into regular, communication between applications on the same system or between different functions in an application program, things like that. Or going in and, for instance, changing the configuration of some of the systems, changing the configuration of any kind of endpoints, any kind of host machines. If you can, I was talking about earlier, the individual motherboards and host machines down at the BIOS level, many of those, most of them actually will allow you to set up an administrative level password that's required in order to make any BIOS changes. And I'm amazed and amused at how many systems engineers and operations folks, they don't set up those passwords. So if somebody compromises a system and, for instance, can elevate the privileges to get down under the covers in the BIOS, they got complete control of that system, you see. So here are different types of host machines that different types of attacks that I can implement on host machines. We talked about the log tampering there. If I gain access to an individual host machine, for instance, that may be running virtual machines, well, escaping out of those virtual machines that I may be logged onto, using the different levels of command insertion and injecting malicious code into, for instance, by way of a web form or a client form there. The majority of the vulnerabilities and the weaknesses, especially down at each individual host machine, is through simple misconfigurations or no configurations, not setting up like administrative level user ID and password protections, things like that. Okay. And taking advantage of, they call it living off the land, taking advantage of and utilizing things that are already on the system. PowerShell, stealing or elevating privileges by some means so I have administrative access, and running PowerShell commands and disabling system functions, erasing system functions, changing the configuration of certain levels of application software so that it acts completely differently than the way it was originally put in play there. Here are some of these top four items right here: Mimikatz, Rubius, Certify, and Seatbelt. Those are all packages, and I guess all but one of those is an open source software and packages, TAC tool suites that are aligned towards specific host-based types of attacks. The Windows recovery environment there, Evil Win RM, your interactive scripting environments there, putting on script programs like Hashcat and Netcat, and even taking advantage of the already installed script level programs, PowerShell and the Bash shell editor, things like that. This LOL bins directory here, that's again living off the land, executing things that are already on the system. And in most cases, that may require you somehow elevating your privileges up so that you have the administrative role on systems. Amazingly simple to steal administrative level credentials. Okay. All types of social engineering techniques that we utilize in order to extract information from people. And, that's why they call social engineering hacking the human, because the human being is the most susceptible and the largest target of hackers and attackers because they're so easy to fool. And there's no doubt about it. Okay. All different types of host-based attacks. Privilege escalation or elevation happens in basically two modes. Horizontal privilege escalation means that, whatever access I gain to a system under whatever credentials, I move horizontally or laterally, hopefully to another user group profile or, trick somebody out of their credentials. So I move laterally to a different user profile. And that user profile, they may not have administrative privileges, but they may have additional and further reaching credentials than I do with my standard user profile. Now, if I do vertical escalation or elevation, it's oftentimes called. That's where I'm taking on higher, hopefully administrative privileges there, which is again keys to the kingdom. Okay. There are very specific programs that are out there that are utilized on different operating systems, Windows and Linux and even Unix-based systems like Mac OS. There's a whole bunch of tools out there that will allow me to escalate the privileges. And again, if I want to do that vertical, like I say, elevation up to administrative, best way to do that is try to steal some credentials. Okay. I wouldn't waste a whole lot of time with, password cracking inline things trying to figure out what the passwords were. I would use some other type of social engineering technique to gain as much high level access as I possibly can by tricking people, hacking the human in essence. Okay. You guys ought to do a look sweep sometime. It may just blow you away. Did me the first time I saw him. A couple of years ago, Jimmy Kimmel, one of his young ladies, one of the producers on the show, went out into the streets of New York and with a man on the street interview kind of thing, and just stopped all different types of people, all different ages of people. And within about 5 minutes of just doing the man on the street interviews, these people were giving her the PIN codes to their credit card number, the password to their bank account. And I mean, just blew me away. They were just giving up this information freely. PIN code for their phones. Okay. And this lady, of course, she was very, very gifted and with her interview technique. And I guess the whole 15 seconds of fame thing sort of kicked in there as well. But within 5 minutes of talking with just this whole range of people, she could have wiped out their bank accounts, stolen their telephone, had access to everything that was on the phone, logged into their online social engineering accounts, Facebook, TikTok, and so on, because they were just freely giving away all of the information that would allow a gifted penetration tester to elevate and escalate privileges into very, very large sections of a large computer network. Also, we have to understand that credentials are stored on individual, especially network server and individual host machines in a very specific location. In the directory services on like a domain network controller, well, that's where all the subjects and objects are identified there network wide. On individual workstations, Windows, for instance, stored credential information in it's a database table. It's called SAM, the Security Accounts Manager database table. Got all the credential information for all the users that are defined on a particular Windows host machine. The local security authorization, LSA. There's another version called LSAAS, different operating system environments. And the directory services in the Windows world is called Active Directory, ADS. In the online cloud-based Microsoft Azure environment, it's Azure Active Directory Services. And then in other operating system environments, all of the credentials are either stored in files that are in like root directories on host machines or in domain level database engines. Sometimes they're stored in encrypted format, sometimes they are not. Okay. So identifying where the credential data may be stored and then gaining access to those areas on systems, unbelievably simple to do. We looked at the Mimikatz utility earlier, that it is concentrated towards credentials, uh, cracking passwords, accessing directory services, databases, and dumping those out, and then take those things offline and then start trying to figure out and crack the passwords rather than trying to do it online, that you might get timed out or blocked out because of invalid login attempts, that kind of thing. Okay. Responder is another suite of products that allows us to do much of those same kind of things there. Mimikat's a pretty cool system there. I gave you guys a link to that earlier there. There are certain things that I can do as a hacker and attacker, certainly, in order to, to sort of do an end run, to circumvent or to circumnavigate around certain types of security tools. I mentioned the living off the land function. If I can gain that access to an individual host machine, and especially if I can elevate my privileges, there is already in the operating system of every computer on the planet some very level deep dive facilities that I can implement, especially if I, like say, can elevate my privileges and gain access to the SAM table, gain access to the directory services, gain access to all the permissions and the encrypted keys that are stored on the system, and figure out what those things are for, a cracking password databases, things like that. So a number of methods that I can utilize to circumvent, circumnavigate, or just blow away individual security configurations on systems in general. This seatbelt tool here is a pretty good scanning tool that is utilized. Let me give you guys a link to the seatbelt tutorial or seatbelt tool suite there as well. Or she blows right there. Um, Safety check, circumnavigation on safety. Sort of a command-based tool. I got another link I'll share with you here as well, where you can get actually all the source code on that if you want to. But let me see, where's the other? Yeah, there's the GitHub. That's it. Yep. Host security, deep dive, host security types of investigation. There's all of the source code. Now, by the same token as all these other tools I told you about earlier, they're not going to get down under the covers and ask you to use these tools on your certification exam. I do want you to realize that that is one of the scanning tools that we use a lot for, more often on the individual host machine and down at the user level information scans, credentials in general, user IDs, passwords, PIN codes, things like that. So it allows me to get to at least the locations of some of these data on different operating system environments. Now, if it's credential, if it's encrypted credential data, you're still going to be viewed in encrypted format. But once again, think about that, password spraying technique. Excuse me. I don't have to unencrypt the information to be able to use it in some very effective ways there. Now, there are also certain things, especially if I'm, breaking into a system and I want to exfil data, if I want to steal some information. Well, there's several different methods that I can utilize to exfil that data. I can encode that data. I gave you the link yesterday to the percent encoding methods there and that cheat sheet. I talked to you yesterday about embedding one file inside of another file. It's called steganography is the term there. And there's programs that utilize certain file types that, well, for instance, JPEG files. Most JPEG files, according to the resolution and the type of JPEG that's being captured, each dot or pixel on a screen is typically a combination of 8 bits, 8 binary bits that determine things such as what's the tint, the color, the hue, the intensity, the brightness of that one dot on a JPEG image screen. Well, in most JPEG images, it only takes 4 and sometimes 5 of those binary bits to define all the attributes and characteristics of that one dot, leaving in some cases 3, in some cases 4 unused binary bits on each byte that is stored for each pixel on the screen, right? Well, steganography software takes a file. Say if I want to steal a file of some sort, whatever file, doesn't matter. Well, those files are stored on a computer system in binary bits, binary data, 1 zeros, 8-bit bytes. So I take those 8 bits and I plug those into the unused bits, for instance, in a JPEG image or an MPEG-4 or even sound files. Okay. Many of those, especially multimedia files, have those leftover unused binary bits in a byte. Okay. And that's what steganography does. It sort of infuses those files and uses those unused binary bits. So when I, send that out in a message or an attachment or an FTP, it looks like a JPEG file, but I have used those unused binary bits to hide my file in. Okay. So I'm exfiltrating that file. And then when it's received on the outside, same steganography software extracts that file from those unused bits. And now I have whatever file it is I stole. So different methods of actually hiding the files or the payloads or whatever it might happen to be inside of, plain looking stuff. I mentioned the alternate data streams. That's another method of sort of packing a file into another file type and making it look like it's something that is not. These are different methods that I can utilize for hiding those payloads to either exfil them out of a system or to execute some malicious software that may be hiding inside of another file. You see. So it's called obfuscation, hiding in plain sight, in essence. Now, I will tell you on the steganography thing, that's much more difficult to do nowadays, especially if organizations have installed these next generation firewalls and intrusion detection systems. Many of those have been primed and programmed, as it were, to look for instance, if it's a JPEG file, they are aware of this type of JPEG doesn't use the last 4 bits, but if there's anything there, that may be a problem. So it will flag that, you see. So changing the nature and the structure of files like that used to be very, very effective from a hacking and attacking perspective. Now there's some other more modernized systems that have caught on to that stuff there. Here is some of the other, we talked about all of these things already thus far. Okay, directory traversal, the cross-site request forgery, cross-site scripting, the taking advantage of misconfigured systems, poorly configured systems, which is still the misconfigurations and the poor credential setup is the largest vulnerability we see in any and all systems. Okay. But these are just some of the methods that I utilize in order to either bypass security systems in general or to take advantage of poorly designed security implementations there as well. It's more often from misconfiguration. The systems operator, systems engineer just not being trained properly to initially harden these devices, change the default configurations, and set them up in a very, very secure mode, you see. So there's many ways I can completely, bypass any attempts, as it were, to further secure a particular environment. There are, I talked about the shell programs and the shell escape there. First, you need to determine what type of shell program or shell editor, shell environment you may be dealing with in a particular system. Then do some research and figure out where the vulnerabilities in that shell environment may indeed happen to be. So you discover it, define it, enumerate it initially, and then figure out where the weaknesses are and see if indeed that is a shell script in controller type of environment that is escapable, or if you need to have elevated or even administrative level permissions to perform some of the things in that shell program that gives you that further access. Now, I talked about a couple of times already these reverse shells. Well, there was reverse listener programs. Netcat is an excellent script program that you can utilize to set up these RATs, they call it, remote access Trojan. And it's only one line of Netcat code that sets the reverse listener up. And it doesn't do anything other than just sits there and monitors an incoming communication port. And if somebody attaches on that port, then whatever you have told by way of the script to do, it can hand over the command line executable. It can make available the configuration file in a Linux system, for instance, or position you into the root directory of a Linux system or a Windows system or a Mac OS system. Doesn't matter. So, and it that runs under the auspice of a particular shell program that sets up that reverse listener program. Okay. So, and those are amazingly simple to set up, I'm going to tell you. Now, there are oftentimes very restricted type of environments, call them kiosks. A restricted environment or a kiosk type of environment may be very limited functionality, and whatever this specific function is designed to do. For instance, consider a card swipe reader as a certain type of kiosk. It has very limited functionality that it does, very limited access into the rest of the network, and it's very specific on the function that it performs. And then extrapolate that and think about any other type of very specific, isolated one or two basic functions that a particular kiosk might happen to provide. Now, some of these kiosks are smaller type of access systems. They'll have like a browser interface or a client side interface. Many of them will have an on-screen type of keyboard interface. Some of them will have an actual keyboard. Sometimes it's full keyboard, QWERTY keyboard. Sometimes it's very limited functionality. Okay. Once I identify the type of kiosk that it happens to be, and where it sits as far as the connectivity to a larger network. And you got to do some background and some research on the specific type of entry point into the system. But you may often find that there are all types of exposed keyboard shortcuts that allow you certain levels of access into these kiosks. Some of them here. Say if it's a kiosk that allows, think about the auto checkout functionality at the grocery store at whatever retail establishment. That's a kiosk, limited functionality kind of thing. Well, a little bit of research on some of those back-end systems will allow you access to their print functions, their file functions, their save functions, their download functions, their connectivity to other kiosks down the line, things like that. So finding out, and these keyboard shortcuts aren't across the board on every kind of kiosk. They do apply to some of the background kiosk operating system and software there. So once you identify the type of kiosk you're actually talking to and the functionality therein, you can crack into systems. And I'll give you an example of that. Some of the first retailers to put these auto checkout systems in place, boy, did they get stung, but they left themselves open. They had very scaled down, very limited functionality, small PC configurations that drove the kiosk functions where people would scan product, pay with their credit card, that kind of thing. Well, a group of ne'er-do-wells, thieves, thugs, and malcontents, shall we say, they did a little investigation on some of these retail establishments, and they realized that the computer system that was driving all this functionality, A, was not locked up, in the kiosk itself. B, had at least one, and some of them had multiple interfaces, USB interfaces, and some of the original ones had what's called RS-232 or DB9 interfaces, multi-plug or multi-pin plugs, and that they were networked together into the larger retail chain network. Okay. So in the wee hours of the morning when nobody was really paying attention, they would sneak in there, open up the back enclosure, plug in their USB flash drives that had their code on it that was stealing the people's credit card numbers with their PIN code, uh, and was storing on the USB flash drive. Everybody that checked out, everybody that paid with a credit card, debit card, whatever, it was capturing all that information on the USB drive. So then they went back, a week later, a couple of days later, again in the wee hours of the morning, and just moseyed by, dropped their glasses on the floor, popped the lid open, pulled their USB flash drive, and then they had thousands of credit card, debit card numbers with the associated PIN codes on those. And they just did their research on the kiosk to figure out how it was configured and where they could plug in and grab that type of information. Okay, so that is in line. You could do the escape functions with the whatever keyboard shortcuts might happen to be available for this particular kiosk. Just got to do a little bit of research there and figure out the functionality of it there and figure out where the vulnerabilities and the weaknesses are there. Okay. Now, there are certain things that I can do as well as far as injecting malicious code into a system. I spoke the other day about these DLLs, dynamic link libraries. They call them DSLs in Windows. In Linux and Unix environment, it's a certain file type called an SO. .so is the file type, but it's a collection of functions is what it is. A collection of callable functions that are oftentimes shared and act in many cases as communication conduits or pipes between either different application programs or different functions inside the same application program. DLLs and SO files are created differently based upon the operating system they're set to run in, basically. Okay. But what they do is provide that usable, sometimes singular function that can be shared among many different applications in the same setup environment, like the Microsoft Office products. Okay. So I can use those things to inject malicious code. DLLs, like I say, it's just a file that contains multiple functions all compiled into a singular object that is utilized by many, many different application programs. Okay. So those are large targets of we ne'er-do-wells, the penetration testers, for writing our own malicious kind of function, dynamic link library function, embedding it into system DLLs. And then anytime any of those functions are called by any of the apps running in that operating system, there goes my malicious code being injected in those as well. Now, that's not, hey, you can fall off the wagon and learn how to do this in a couple hours. You have to understand application programming. You have to understand how DLLs or SOs work in Linux environments. And you have to program those and then embed it inside of typically an existing dynamic link library collection. Now, I will tell you that it also is becoming more and more difficult to be successful in that because everybody's thinking security nowadays, and many network engineers and security admins are setting up it's actually a check on all of the system files. These files, the signature and the structure and the change dates on those things should not change unless you have some kind of update that is that is applied to these things. It should be the same file today as it is 6 months from now, unless you do some kind of system update. Okay. So they're using these file management functions there and checking those, in essence, those hashes, those signatures of those files on a very regular basis. And if they see that the signatures change from yesterday to today, they know something's up. Then they look and they say, well, we haven't made any system updates, so there shouldn't be these changes in that DLL. We better pull it and analyze it and see if somebody's crammed some code in there, kind of thing. Okay. But that's called library injection, injecting those library objects and modules inside of the pre-existing system ones. Okay. Injection, hollowing, injecting malicious code inside of a maybe even a DLL or a program function. I told you guys earlier in the week, usually when we start up a program, if you write the program properly, if there are any program variable fields that are accessed or being used, it will go ahead and attempt to allocate that space, reserve that space, call it object allocation, in main memory. There are certain areas of main memory when I run an application program that I want to be reserved. I want to be, in essence, protected. Okay. If I then am capable of shimming in some malicious code into even the DLLs, okay, then I might be able to inject that malicious code up into main memory and even have it in some cases called memory resident. That is also referred to as fileless malware. Okay, it's not coming out of a file off of a disk. It is just inserted in main memory by maybe even a script level code or something like that. Okay. It also utilizes, it replaces in essence some of the actual legitimate code with malicious code that runs in main memory. And there are protected memory spaces as well that if I corrupt those when an application program, even parts of an operating system, I can plug in malicious code to run in protected spaces of memory and corrupt the whole environment there. Okay. So here's the individual. They call it hollowing and injection first. First, I hollow out areas of main memory that typically are protected. And I have to do that by, in essence, turning off a memory suspension tag, they call it. And there's script programs out there that will actually assist me in doing this kind of thing. So whereas a particular program would insert some application code into a protected area of main memory, well, my process would turn off the flag that protects that, allow me to insert my malicious code in that protected memory space, and then run that code. So whatever malicious code I had written there would be executed instead of the reserved code that may have been put up there by an operating system function or any of those DLLs, those kind of things there as well. Okay. So now, again, on your exam, you're not going to have to do this. Okay. But this is just yet another means of removing legitimate code, inserting malicious code, and having the system process that for whatever end result I'm looking for: corrupting data, stealing data, locking down systems, crashing systems, whatever. Now, I talked about the logs. Every system in a network environment, doesn't matter what it is, routers, switches, gateways, personal computers, telephones, server class machines, every endpoint in an entire network, database engines, all of those generate some kind of log. Okay. And they do it automatically unless an operator or a security person goes in there and turns the logging off, which they never do. Okay. There are certain things that I can do in there, basically designed to sort of hide the things that I've done. Now, you can delete logs, or you can inject additional log entries in and overlay and change log entries, things like that. But even those processes are logged. So corrupting the logs, modifying the logs, changing the date and time stamp on certain log entries, things like that. That's how you actually tamper with the logs and move stuff around so that you're not raising any big red flags while you're in there doing the penetration testing stuff. Okay. Now, a good, savvy security practitioner, and the ones that make a living at it, they'll tell you 25, 30% of their day, every day, is involved with reviewing logs, looking for these triggers that highlight that there's been some malfeasance going on in their networks. So any and everything I can do as a penetration tester to hide that stuff, to hide those red flags, I should indeed do so. Okay. Even in some cases, maybe up to the point of just disabling the logging, you know, but that is logged. the, the act of disabling a log is logged. So, okay. There are this unquoted service path thing here. That's another injection method. It's utilized to run executable code, whereas in the quoted version of it, it treats it as text rather than executable code. If you take the quotes off of these strings, especially in service paths that Windows uses under the covers to run code or to put log entry information in, that kind of thing. Well, if I take the quotes off of that, the system treats it as something, a file or a folder, an executable program. Okay. So now not all of them will accept that. You just have to identify the service paths. You have to identify what they're doing inside the environment, and determine if indeed it will actually run malicious code if you remove the quotes out of some of these directory service paths and documentation information. Okay. So that's yet another means of injecting malicious code into, in this case, specifically a Windows type of environment there. The thing about the logs, which is very, very important, and this is things that security practitioners, like I was saying, they spend a large majority of their time every day. Well, not a majority, at least a 20-25% time, especially if they're doing it manually, in doing log review. Because that's where you pick up the information on, every action or inaction or every program that's run, everything that is occurring in the entire enterprise is logged somewhere. Okay. Um, the thing about from a security practitioner perspective, keeping these logs of information and analyzing and reviewing those logs, especially over a period of time, well, you begin to pick up patterns. And those patterns then are what we utilize in order to further fine tune our security systems, the entire security apparatus end to end. Okay. And it's all based upon documentation. Now, I told you guys earlier, security professionals need to learn scripting languages so that they can automate as much of this stuff as possible rather than spending that 20-25% of their day every day typing the same old mundane commands, doing the string searches, looking for this error code, looking for that error code. Script it and automate all of that stuff. Okay. So documentation, and then document the documentation. Very, very important. Same thing when you're doing pen testing. You got to document everything. You got to document everything to know what you did and what you're going to need to undo. That's why I'm so high on learning the scripting languages. Python specifically now is my choice, because I can use the comment section in it for the documentation, and I can use the inverse scripting to set everything back to the way or better than it was before I started my engagement there. Okay. So very beneficial as far as documentation in every side of it. The hackers, the attackers, or the defenders, either one, document everything. So that was the module summary here. Though what we intended to do here was to look at more from the network, the enterprise side, as far as the attacks, and then drill on down into the host-based attacks specifically. There are a whole host of tools that are available out there to perform these individual types of attacks right down on individual host systems. I gave you links and listing of many of those tools. Now, there's a couple of lab exercises that I'm going to assign for you guys, probably as homework tonight, where you will use several of the tools that we talked about throughout this lesson lecture here. You're going to get your hands on the SQL Interactive tool suite for injecting SQL code. We'll look at a couple of the other tool suites and you actually using those to do some further investigation into some of these attack methods as well. So you'll roll up sleeves and get some hands on some of these things. You'll use Wireshark, okay, as far as capturing and analyzing and evaluating data frames as they flow across network connections, things like that. All right, for those of our friends who are joining us on YouTube, I am about to turn that down for the lunch break. Thank you all for joining us, and you are certainly welcome to join us later on this afternoon. We're going to be taking about an hour and a half break now, and then we will be back online, living and breathing on the insides later on this afternoon. For now, thank you very much for joining us, and I hope you got the detail out of it that you wanted. Be sure to contact some of our sales reps and take some of the classes. I think you might have fun. And the byproduct is you might learn something new there as well. So thank you all for joining us, and look back later on this afternoon.